Hello, in this lecture we'll find out the length of line segment X. In the drawing we have a regular hexagon. The regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. And we know that side AB equals to 2 units of this regular hexagon A, B, C, D, E, F. Therefore, all the other sides of this regular hexagon must be also equal to 2 units. So we can write down that side BC equals to 2 units, side DC equals to 2 units, side ED equals to 2 units, FE equals to 2 units, and finally side FA also equals to 2 units. And all those 6 interior angles of this regular hexagon are also equal to each other. And we also know that line segment PB equals to 3 units. This line segment PB equals to 3 units. And our mission is to find out the length of side PA or line segment PA that is equal to X. We have to find out the value of X. Okay, so first of all, we'll find out the sum of the angles in any regular hexagon, like this regular hexagon A, B, C, D, E, F. So we draw regular hexagon. It could be any regular hexagon, and we find out the sum of the angles in that regular hexagon. This is regular hexagon. A, B, C, D, E, F. In order to find out the sum of the angles, the sum of the interior angles in this regular hexagon, we will join points B and E together by a straight line. By joining points B and E, we created here 2 quadrilaterals, those 2 quadrilaterals. Quadrilateral ABFE, this quadrilateral, and quadrilateral BCED. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles of quadrilateral ABFE is equal to 360 degrees. And the sum of the angles of quadrilateral BCDE, it is also equal to 360 degrees. And because of the fact that this regular hexagon consists exactly those 2 quadrilaterals, it means that the sum of the angles in those 2 quadrilaterals will be equal to to the sum of the angles in this regular hexagon A, B, C, D, E, F. So the sum of the angles in those two quadrilaterals is 360 degrees plus 360 degrees, that is actually 720 degrees. And that is exactly the sum of the angles in this regular hexagon. So we actually found out that the sum of the angles in any regular hexagon equals to 720 degrees. Why? Because of the fact that this regular hexagon A, B, C, D, E, F could be any regular hexagon. And what is the size of one interior angle of this regular hexagon? We have 6 interior angles, 2, 4, 6. We want to know what is the size of one out of the 6 interior angles in this regular hexagon A, B, C, D, E, F. And because of the fact that the sum of the 6 angles it is equal to 720 degrees, and in total we have in any regular hexagon 6 equal angles, 6 equal interior angles. So we have to divide the sum of the total angles, that is 720 degrees, by the number of the interior angles, that is 6. 720 degrees over 6 is 120 degrees. So we found out that each interior angle of this regular hexagon equals to 120 degrees. Okay. So each interior angle out of the 6 interior angles of this regular hexagon will be equal to 120 degrees in its size. So this angle equals to 120 degrees. This angle equals to 120 degrees. This interior angle equals to 120 degrees. This interior angle equals to 120 degrees. This interior angle equals to 120 degrees, and this interior angle it is also equal to 120 degrees. In the next step, we will extend side DC by a straight line. So DC is one side out of the 6 sides of this regular hexagon. Therefore, it is absolutely a straight line. And when you extend a straight line by a straight line, the result must be a straight line. We define this point as L. So DL is a straight line. Okay, so we write it down that line segment DL is a straight line, because when you extend a straight line by a straight line, the result must be a straight line. And we also have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the left side, this side of the straight line DL, at point C, according to rule number 1, the sum of the angles must be equal to 180 degrees. So which angles we have at the left side of the straight line DL at point C? We have this angle that is equal to 120 degrees, plus the missing angle that is actually angle BCL. So 120 degrees plus the missing angle BCL, in total they must be equal to 180 degrees according to rule number 1. Here we subtract 120 degrees from this equation, and we get that the missing angle BCL equals to 180 degrees minus 120 degrees, it is 60 degrees. Okay, so I found out that this missing angle BCL equals to 60 degrees in its size. In the next step, from point B, we draw perpendicular on DL. Okay. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point B and DL as M. By doing this construction, we get that here triangle BMC, that is a right triangle. So we copy triangle BMC in a new page and we will analyze it. So this is actually the right triangle, triangle CMB, that I copied from the original drawing. Angle BCM or MCB equals to 60 degrees according to rule number 1. This angle equals to 90 degrees. Angle CMB equals to 90 degrees according to our construction. And so the hypotenuse CB equals to 2 units because it is 1 out of the 6 sides of the regular hexagon, and we know that all the sides of any regular hexagon are equal to each other, and because of the fact that side AB equals to 2 units, therefore all the other sides must be also equal to 2 units. Therefore CB equals to 2 units. So in this right triangle, triangle CMB, cosine 60 degrees equals to CM over CB. Cosine 60 degrees equals to CM over CB. Okay, CM over CB, the hypotenuse CB. Cosine 60 degrees equals to 1/2. So we substitute cosine 60 degrees by 1/2. And it is equal to CM. CM is the missing side, so we leave it as it is, over CB. CB, the hypotenuse CB equals to 2 units, therefore we substitute CB by 2. In conclusion, we found out that 1/2 equals to CM over 2. Here we will multiply this equation by 2, and we will get that CM equals to 1 unit. CM equals to 1 unit. You can write down in the original drawing 1 unit. that cm equals to 1 unit. Likewise, if we continue to focus on the right triangle CMB, in this right triangle, sinus 60 degrees equals to MB over CB. Okay, sinus 60 degrees equals to MB over the hypotenuse CB. Sinus 60 degrees is square root of 3 over 2, so we substitute sinus 60 degrees by square root of 3 over 2, and it is equal to MB. MB is the missing side, so we leave it as it is, over CB. CB equals to 2 units, therefore we substitute CB by 2. Here we will multiply this equation by 2, and we get that MB equals to the square root of 3 units. MB equals to the square root of 3 units. You can write down in the original drawing that MB equals to the square root of 3 units. In the next step, we will focus on the right triangle, triangle PMB. First of all, side PM equals to PC plus CM. Again, PM equals to PC plus CM. CM equals to 1 unit, PC is unknown, so we define PC as A, and therefore side PM equals to PC plus CM. PC plus CM is A plus 1. So PM equals to A plus 1. Side PM equals to the square root of 3 units, and the hypotenuse PB equals to 3 units according to what is given as the question. So I'll copy the right triangle, triangle PMB in a new page, and we'll implement in this right triangle PMB the Pythagoras theorem. So actually, this is the right triangle, triangle PMB that I copied from the original drawing. Side PM equals to A plus 1, side PM equals to the square root of 3, and the hypotenuse PB equals to 3 units according to what is given as the question. So we will implement the Pythagoras theorem on this right triangle, triangle PMB. Here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares for the perpendiculars. The hypotenuse in this right triangle PMB is PB, therefore the square of the hypotenuse is PB squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM squared plus bm square. In conclusion, we found out that according to the Pythagoras theorem, in the right triangle PMB, PB square equals to PM square plus PM square. PB equals to 3 units, therefore PB square is 3 squared, that is 9. And it must be equal to PM square. PM is A plus 1, therefore PM square is A plus 1 square plus BM square. BM equals to the square root of 3 units, therefore BM square is the square root of 3 square. So 9 equals to A plus 1 square plus square root of 3 square. Square root of 3 square is 3. So 9 equals to A plus 1 square plus 3. Here we subtract 3 from this equation, and we will get that 9 minus 3 is 6. Therefore 6 equals to A plus 1 square. Here we take a root out of this equation, and we will get that the square root of 6 equals to A plus 1. Here we subtract 1 from this equation, and we get that A equals to the square root of 6 minus 1 units. Okay. So we can write down in the original drawing that A equals to the square root of 6 minus 1 units. Okay. In the next step, we'll join points A and C together by a straight line. By joining points A and C, we created triangle ABC. This is triangle ABC. Okay, this is triangle ABC. Angle ABC, this angle equals to 120 degrees because of the fact that it is one out the 6 interior angles of this regular hexagon. And all the angles of this regular hexagon are equal to each other. Each of them is equal to 120 degrees, therefore angle ABC equals to 120 degrees. Side AB equals to 2 units, and side BC equals to 2 units because of the fact that those two sides, they are the sides of this regular hexagon, and we know that all the sides of any regular hexagon are equal to each other, and in this specific regular hexagon, one side equals to 2 units, AB equals to 2 units, therefore all the other sides are also equal to 2 units. Therefore BC is also equal to 2 units. So we will implement the law of cosines in this triangle, triangle ABC, in order to find out the length of side AC. Okay. So I will remind you what is the law of cosines. The law of cosines is true in any triangle. So if we have a triangle ABC, that could be any triangle, not necessarily our triangle, but any other triangle. This is triangle ABC. We know that the length of side AB is equal to A units, side AC equals to B units in its length, side BC equals to C units in its length, and the angle between side AB and side AC is theta. And according to the law of cosines, this law, we get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, repeat again, C squared, C is the length of side BC, equals to A squared, A is the length of side AB, plus B squared, B is the length of side AC, minus 2 times A times B times cosine theta. Theta is the angle between side BA and side CA, or angle BAC in triangle ABC. Okay, so we'll implement the law of cosines in our triangle ABC. So I'll copy triangle ABC, this triangle ABC, in a new page, and we'll implement the law of cosines in this triangle ABC in order to find out the length of side AC. So actually this is triangle ABC that I copied from the original drawing. Angle ABC equals to 120 degrees. It is one out of the 6 interior angles of the regular hexagon. Side AB equals to 2 units, side BC equals to 2 units. They are both the sides of the regular hexagon. So we'll implement in this triangle ABC the law of cosines in order to find out the length of side AC. So according to the law of cosines, we get that AC squared equals to AB squared plus CB squared minus 2 times AB times CB times cosine 120 degrees. This equation is the implementation of the law of cosines in our triangle ABC. Repeat again, AC squared equals to AB squared plus BC squared minus 2 times AB times BC times cosine 120 degrees. So AC squared equals to AB squared. AB equals to 2 units, therefore AB squared is 2 squared, that is 4. Plus BC squared. BC equals to 2 units, therefore BC squared is 2 squared, that is also 4. Minus 2 times AB is 2. BC is also 2 times cosine 120 degrees. Cosine 120 degrees equals to minus 1/2. Okay. So actually, this expression we have minus times minus, that is plus. So This expression in total will be a positive number. So 2 times 2 is 4, and 2 over 2 is 1. So those two will get cancelled, and we left only with 4. So in conclusion, we found out that AC squared equals to 4 plus 4 plus 4. So AC squared four plus 4 plus 4 is 12. Here we substitute 12 by 4 times 3. So AC squared equals to 4 times 3. Here we take a root out of this equation, and we get that AC equals to the square root of 4 times 3. We take 4 out of the root. The square root of 4 is 2. So we found out that AC equals to 2, and inside the root we left only with 3. AC equals to 2 times square root of 3 units. This side AC equals to 2 times square root of 3 units. AC equals to 2 times square root of 3 units. Okay, we continue to focus on triangle ABC. We find out the sizes of those two angles. We know that side AB equals to side BC, they are both equal to 2 units, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides there are two equal angles. Those two angles that are located in front of the equal sides, AB and BC, must be equal to each other. So if this angle equals to x, then this angle must be also equal to x. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle ABC, the sum of its angles must be equal to 180 degrees. So which angles we have in triangle ABC? We have x plus x plus 120 degrees. In total, they must be equal to 180 degrees. X plus x is 2x plus 120 degrees equals to 180 degrees. Here we subtract 120 degrees from this equation, and we will get that 2x equals to 180 degrees plus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees, we divide this equation by 2, and we get that x equals to 60 degrees over 2, it is 30 degrees. So we actually found out that this angle x equals to 30 degrees, and this angle x, it is also equals to 30 degrees, and this angle is actually angle ACB. So angle ACB equals to 30 degrees. So we can write down in the original drawing that this angle ACB equals to 30 degrees. Okay, angle ACB equals to 30 degrees. We have the big angle PCB equals to 120 degrees. The small angle ACB equals to 30 degrees, and therefore the missing angle, that is to say angle PCA, will be equal to the big angle minus the small angle. That is to say the big angle is PCB minus the small angle ACB must be equal to the missing angle PCA. So I will draw the three angles in a new page, and you will see the picture much more clearer. We have the big angle PCB. This is the big angle PCB that is equal to 120 degrees. Okay, angle PCB equals to 120 degrees. The small angle ACB equals to 30 degrees. This is the small angle ACB that is equal to 30 degrees. And therefore, the big angle PCB minus the small angle ACB will be equal to the missing angle PCA. So, the missing angle PCA this is the missing angle, will be equal to the big angle, that is angle PCB, the big angle, minus the small angle, that is angle ACB. Okay? So the missing angle PCA will be equal to the big angle PCB that is equal to 120 degrees minus the small angle ACB that is equal to 30 degrees. So the missing angle PCA equals to 120 degrees minus 30 degrees, it is 90 degrees. So we found out that this missing angle PCA equals to 90 degrees. That is to say, it is a right angle. Angle PCA equals to 90 degrees. And because of the fact that angle PCA is a right angle, it means that triangle PCA it is also a right triangle. This triangle PCA is a right triangle because of the fact that this angle PCA is a right angle. Repeat again, the green triangle PCA is a right triangle because angle PCA is a right angle. This is a right triangle. So I will copy the right triangle PCA in a new page and will implement the pattern as shown in this right green triangle PCA. So actually this is the right green triangle PCA that I copied from the original drawing. Side PC equals to the square root of 6 minus 1 units. It is actually A. A equals to the square root of 6 minus 1 units. AC equals to 2 times square root of 3 units. Here AC equals to 2 times square root of 3 units. And here AP is the equals to X. This is the line segment that we are looking for. So by implementing here the Pythagoras theorem, we will find out the length of X. So here by PT, it is the evolution from Pythagoras theorem. In any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle is AP, therefore the square of the hypotenuse is AP square. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to PC square plus AC square. So AP equals to X, therefore AP square is X square, and it must be equal to PC square. PC is square root of 6 minus 1, therefore PC square is square root of 6 minus 1 square plus AC square. AC is 2 times square root of 3, therefore AC square is 2 times square root of 3 square. In conclusion, I found out that X square equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. 2 times square root of 3 square is 2 square, that is 4, times square root of 3 square, that is 3. 4 times 3 is 12. So in total this expression equals to 12. Okay. In the next step we find out the value of the expression square root of 6 minus 1 square by using the algebraic identity that states that a minus b square equals to a square plus b square minus 2 times a times b. In our specific expression, a equals to the square root of 6 and b equals to 1. Okay? And according to this algebraic identity, a minus b square equals to a square. A is square root of 6, therefore a square is square root of 6 squared, that is 6, plus b square. B is 1, so b square is 1 squared, that is 1, minus 2 times a is square root of 6 times b is 1. In conclusion, we found out that square root of 6 minus 1 square equals to 6 plus 1, that is 7, minus 2 times square root of 6. So actually we can substitute square root of 6 minus 1 square in this equation by 7 minus 2 times square root of 6. So we'll do it now, and we'll get that x square equals to the square root of 6 minus 1 square is 7 minus 2 times square root of 6 plus 12. So x square equals to 7 plus 12 is 19 minus 2 times square root of 6. So here we take a root out of this equation and we get that x equals to the square root of 19 minus 2 times square root of 6. Or in terms of numbers, it is equal to 3.755 units. That is the answer to the question. The length of this line segment AP is equal to x. It is equal to either the square root of 19 minus 2 times square root of 6, or in terms of numbers, x equals to 3.755 units. Okay, in the next step I will summarize the lecture. In the drawing, We have a regular hexagon. A regular hexagon is a closed polygon with 6 equal sides and 6 equal angles. We know that one side of this regular hexagon AB equals to 2 units, therefore all the other sides are also equal to 2 units, and also all of its 6 interior angles are also equal to each other. And we also know that line segment PB equals to 4 units. Our mission is to find out the length of line segment PA that is equal to x, to find out the value of x. So first of all, we found out what is the sum of the angles, the sum of the 6 interior angles in this in any regular hexagon. So I draw here regular hexagon A, B, C, D, E, F. That will be any regular hexagon. And we found out what is the sum of the angles in this regular hexagon. In order to find out the sum of the angles in this regular hexagon, we join points B and E. By joining points B and E, we created here 2 quadrilaterals. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. So the sum of the angles in quadrilateral ABFE equals to 360 degrees, and the sum of the angles in quadrilateral BCED is also equal to 360 degrees. And the sum of the angles in both quadrilaterals will be equal to the sum of the angles in this regular hexagon ABCDEF. So the sum of the angles in those two quadrilaterals, it is equal to 360 degrees plus 360 degrees, this is 720 degrees. So we found out in conclusion that the sum of the angles in any regular hexagon, it is equal to 360 degrees, to 720 degrees. Okay, and the size of one angle, the size of the one interior angle in this regular hexagon will be equal to the sum of the 6 interior angles, that is actually 720 degrees, over the number of the angles, that is 6. Why? Because all of the 6 interior angles are equal to each other. So 720 degrees over 6 is equal to 120 degrees. So we found out that each interior angle is equal to 120 degrees. So we can write down here that all the 6 interior angles, they are equal to 120 degrees. Then we extended side DC by straight line. In this way, created line segment DL. DC is one side of the regular hexagon, therefore it is absolutely a straight line. And when you extend the straight line by straight line, the result must be a straight line. So DL, therefore it is a straight line. Okay, so here DL is a straight line, and we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the left side of the straight line DL at point C, here the sum of the angles must be equal to 180 degrees according to rule number 1. So which angles we have at the left side of DL at point C? We have this angle is equal to 120 degrees plus the missing angle BCL. So 120 degrees plus the missing angle BCL, in total they must be equal to 180 degrees according to rule number 1. We subtracted 120 degrees from this equation and found out that the missing angle BCL equals to 60 degrees. This angle BCL equals to 60 degrees. Then from point B we draw perpendicular on DL, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DL as M. By doing this construction, we created here the right triangle BCM. So we call it the right triangle BCM in a new page, and we implemented here the hypotenuse, and we analyze this triangle. This angle equals to 90 degrees according to our construction, and this angle equals to 60 degrees according to rule number 1. And CB equals to 2 units because it is one side out of the 6 sides of the regular hexagon, and all of its sides are equal to 2 units. So in this triangle CMB, the right triangle CMB, we know that cosine 60 degrees equals to CM over CB. CM over CB. So cosine 60 degrees is 1/2, so we substitute cosine 60 degrees by 1/2, and it is equal to CM over CB. CB is 2. Here we multiply this equation by 2 and found out that CM equals to 1 unit. Here CM equals to 1 unit, here we can write down that CM equals to 1 unit. Likewise, we continue to focus on this right triangle, triangle CMB, this right triangle, triangle CMB, sine of 60 degrees equals to MB over CB. Sine of 60 degrees equals to MB over CB. Sine of 60 degrees is square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2, and it is equal to MB over CB. CB is 2, so in conclusion, we found out that square root of 3 over 2 equals to MB over 2. Here we multiply this equation by 2, and found out that MB equals to square root of 3 units. Here MB equals to square root of 3 units, and here also MB equals to square root of 3 units. Okay, then we focused on the right triangle, triangle and PMB. PC is unknown, therefore we defined PC as A and CM equals to 1. So PM in total will be equal to PC plus CM, that is A plus 1. MB equals to square root of 3 units, and PB equals to 3 units according to what is given us the equation. So I copied the right triangle, triangle PMB in a new page, and we implemented the Pythagoras theorem on this right triangle, triangle PMB in order to find out the value of A. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle is PB, therefore the square of the hypotenuse is PB square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to PM square plus BM square. So PB is the hypotenuse PB is 3, therefore the square of the hypotenuse is PB square, that is 9, plus PM square. PM is A plus 1, therefore PM square is A plus 1 square, plus BM square. BM is equal to 3, therefore BM square is equal to 3 square. So 9 equals to A plus 1 square, plus square root of 3 square. Square root of 3 square is 3. So we found out that 9 equals to A plus 1 square plus 3. Here we subtracted 3 from this equation and found out that 9 minus 3 is 6. So 6 equals to A plus 1 square. Here we took a root out of this equation and found out that the square root of 6 equals to A plus 1. Here we subtracted 1 from this equation and found out finally that A equals to the square root of 6 minus 1 unit. So we can write down in this here in the original domain that PC that is equals to A equals to the square root of 6 minus 1 units. Okay, then we joined points A and C together by straight line. By joining points A and C, we created a triangle ABC. In this triangle ABC, this angle ABC equals to 120 degrees because it is one out of the 6 interior angles of this regular hexagon, and we know that all the interior angles of this regular hexagon are equal to each other. Each of them is equal to 120 degrees. AB equals to BC equals to 2 units because of the fact that those two sides are two sides of this regular hexagon, and we know that all the sides of the regular hexagon are equal to 2 units. So I copy triangle ABC. In the new page, we actually implemented the law of cosines in this triangle, triangle ABC. What is the law of cosines? The law of cosines is true in any triangle. So here we have the triangle ABC that could be any triangle. Side AB equals to units, side AC equals to B units in its length, and side BC equals to 3 units in its length. And the angle between side AB and side AC is theta. Then, according to the law of cosines, we will get that C square equals to A square plus B square minus 2 times A times B times cosine theta. So we actually can implement the law of cosine, this law, in our triangle ABC. So I call it triangle ABC in new page. This is triangle ABC. We implemented the law of cosines in this triangle, triangle ABC, in order to find out the value of AC, the length of side AC. According to the law of cosines, we get that AC square equals to AB square plus BC square minus 2 times AB times BC times cosine 120 degrees. AC square equals to AB square plus CB square minus 2 times AB times CB times cosine 120 degrees. AC square equals to AB square. AB is 2, so AB square is 2 squared, that is 4, plus CB square. CB is 2, therefore CB square is 2 squared, that is 4, minus 2 times AB is 2, and CB is also 2, and cosine 120 degrees, it is minus 1/2. So this expression, in total, it is a positive because minus times minus is plus. And 2 times 2 is 4, and 2 over 2 is 1. So in total, this expression equals to 4. Therefore, AC squared equals to 4 plus 4, that is 12. We substitute 12 by 4 times 3. So AC squared equals to 4 times 3. Here we took out of this equation, and we found out that AC equals to the square root of 4 times 3. The square root of 4 is 2, so in total, this expression AC equals to 2 times square root of 3. Here we can write down that AC equals to 2 times square root of 3. Then we continue to focus on triangle ABC. We found out the sizes of those two angles. We know that side AB equals to side BC. They are both equal to 2 units, therefore they are equal to each other. And we know that in any triangle, in front of equal sides, there are equal angles. So in front of those two equal sides, AB and BC, we have those two angles that must be equal to each other. So if this angle equals to x, then this angle must be also equal to x. And you know that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in triangle ABC? We have x plus 120 degrees. In total, they must be equal to 180 degrees. X plus x is 2x. So 2x plus 120 degrees equals to 180 degrees. Here we subtracted 120 degrees from this equation and found out that 2x equals to 180 degrees minus 120 degrees, it is 60 degrees. So 2x equals to 60 degrees. We divided this equation by 2 and found out that x equals to 30 degrees. Here x equals to 30 degrees, and here also x equals to 30 degrees. This angle, it is angle ACB. So angle ACB equals to 30 degrees. We can write down here that this angle, angle ACB equals to angle ACB equals to 30 degrees. Okay. So we have the big angle PCB that is equal to 120 degrees. We have the small angle ACB that is equal to 30 degrees, and therefore the missing angle, that is to say angle PCA, will be equal to the big angle minus the small angle. Repeat again. The big angle PCA equals to 120 degrees. The small angle ACB equals to 30 degrees, therefore the missing angle PCA must be equal to the big angle PCB minus the small angle ACB. So the missing angle PCA equals to the big angle PCB minus the small angle ACB. So the missing angle PCA equals to the big angle PCB that is equal to 120 degrees minus the small angle ACB that is equal to 30 degrees. So in conclusion, we found out that this missing angle PCA equals to the big angle 120 degrees minus the small angle ACB, that is 30 degrees. 130 degrees minus 30 degrees, it is 90 degrees. So we found out that the missing angle PCA equals to 90 degrees, that is to say it is a right angle. And because of the fact that the angle PCA is a right angle, therefore triangle PCA is a right triangle. So this is the green triangle, is triangle PCA, and we know that is a right triangle. This angle equals to 90 degrees, therefore the green triangle, triangle PCA, is a right triangle. So I copy triangle PCA in a new page, and we implemented the Pythagoras theorem in this right green triangle, triangle PCA. This is right triangle, triangle PCA that I copied from the original drawing. AP equals to x, this is the missing line segment that we are looking for. PC equals to the square root of 6 minus 1, it is A. And AC equals to 2 times square root of 3 units. And according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AP, therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to PC squared plus AC squared. AP is x, therefore AP squared is x squared. Plus PC squared. PC is square root of 6 minus 1, therefore PC squared is square root of 6 minus 1 squared. plus AC square. AC is 2 times square root of 3, therefore AC square is 2 times square root of 3 square. So x squared equals to the square root of 6 minus 1 square plus 2 times square root of 3 square. 2 times square root of 3 square equals to 2 squared, that is 4, times square root of 3 square, that is 3. 4 times 3 is 12. So in conclusion, we found out that x squared equals to the square root of 6 minus 1 square plus 12. So we found out the value of this expression, square root of 6 minus 1 square, according to the algebraic identity that states that a minus b squared equals to a squared plus b squared minus 2 times ab. In our specific expression, square root of 6 minus 1 square, a equals to the square root of 6 and b equals to 1. And according to this algebraic identity, we get that this expression equals to a squared. A is square root of 6, therefore a squared is square root of 6 squared, that is 6. Plus b squared. B is 1, so b squared is 1 squared, that is 1. So we have 6 plus 1 minus 2 times ab. Minus 2 times a is square root of 6 and b is 1. So in conclusion, I found out that square root of 6 minus 1 square equals to 6 plus 1 minus 2 times square root of 6. 6 plus 1 is 7. So in conclusion, this expression square root of 6 minus 1 square equals to 7 minus 2 times square root of 6. Therefore, we can substitute square root of 6 minus 1 square by 7 minus 2 times square root of 6. We did it and we got that x squared equals to the square root of 6 minus 1 square is 7 minus 2 times square root of 6 plus 12. So x squared equals to 7 plus 12, that is 19, minus 2 times square root of 6. We took out of this equation and found out that x equals to the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, x equals to 3.755 units. If the value of line segment AP is equal to x equals to either the square root of 19 minus 2 times square root of 6 units, or in terms of numbers, AP is equal to x equals to 3.755 units. Okay, thank you very much.